Today we are going to begin looking at Chapter 7. Chapter 7 is going to deal with quadrilaterals. So we just finished triangles, our three-sided polygons. Now we're going to move into quadrilaterals. Remember, a quadrilateral is simply defined as a four-sided polygon. Polygon meaning it has to have straight sides and they have to all connect. It can't be left open. So when we are looking at classifying quadrilaterals, they fall into two groups, first of all. I mean, there are things that are only a quadrilateral, and that's it. They don't have any other definition to them whatsoever. But for those that aren't going to be into that category, which is most of our quadrilaterals, they fall into either parallelograms or non-parallelograms. It's kind of like just a shoot-off. So a parallelogram, by definition, has two sets of opposite parallel sides. So when you think that through, you think about the fact that you would have two sets of opposite parallel sides. So my question to you is this a parallelogram? Remember, you cannot assume anything at all to be true. You can only use something that's marked. So you can't look at a shape and go, yeah, that's a parallelogram. Now, I will tell you it is because I drew it to be a parallelogram, but you can't look at it and say, yes, that is a parallelogram, without first having some information to go off of. So if it is going to be a parallelogram, it has to have certain things true about it. The definition is that it has two pairs of opposite parallel sides. So we use little triangles like that to represent parallel. So this one has two triangles and two triangles. They're opposite sides. They're the sides that don't touch each other. And then this pair would also need to be marked as parallel. Remember, parallel lines will go side by side, never touch each other at all. Now, the name parallelogram has parallel in it. So, to me, the definition of this particular term basically just sticks out like a sore thumb. So that's going to lead me into the next drawing. So I want you to take a second, take a piece of paper, and trace your hand on it for me. Okay, hopefully you took a moment and traced your hand. Here's my hand. And we're going to label this particular drawing proving parallelograms. And we're using our hand because there are 5 ways to prove something is a parallelogram. And I'm going to talk about labeling each of your fingers and why we would choose that finger and that kind of thing. So the first thing we're going to do is go to our thumb, and I use this one because to me it sticks out like a sore thumb. So if on your diagram you have labeled two sets of opposite parallel sides, then you know by definition that that figure is going to be a parallelogram. And I'm just going to jot a little picture over here, and this is the one we just did. So we would need to see parallel opposite sides and parallel opposite sides. So we would need those little triangles on them. Sometimes they'll leave them open, sometimes they'll get filled in. That's not really important, it's just that little triangle marking that indicates parallelism. All right, then your first 2 fingers, because these are the top 2 that people tend to remember, is it will be a parallelogram if you have 2 sets of opposite congruent sides. So that one, in its diagram, the opposite sides will be the same length. So the 2, in this case, longer sides, and then the 2 shorter sides, but you have to have both pair marked as opposite congruent sides. Now the one that goes with that, the other one that people tend to remember, so these are the top 2, that's why there are main 2 fingers here, is it will be a parallelogram if you have 2 sets of opposite congruent angles. So in the diagram for this one, we would have marked for us the opposite angles. So this one and this one, the ones that are not right next to each other, those two would need to be marked as congruent, and the other pair would need to be marked as congruent. You need to have two sets or two pairs of opposite sides, or two pairs or two sets of opposite angles. They have to come in pairs like that. If you just have one pair of opposite angles, that's not enough. You have to have two pairs or two sets. All right, then we get to the ring finger. So for our ring finger, this one is kind of different, and that's why I put it here, because your ring finger is different from all your other fingers. It's supposed to symbolize something if you wear a ring on that finger that doesn't represent, a ring on any other finger doesn't represent that same thing. It's different. So this one is one pair of opposite sides, congruent and parallel. So here it's one pair. So you'll notice that's different from all the others, right? The others were two sets, two sets, two sets. This is one pair. So for this one, we can have on our figure, maybe the only thing we know is that this side and this side are congruent, but that's not enough. They can't just be congruent. They have to be congruent and parallel. So you have to have two markings on one set or one pair. All right, then we get to our last one, and I like to use this as my pinky finger because when I hold my hand out, my pinky kind of goes off at an angle. If I try to put my hand straight up, then my pinky finger over here kind of goes off at an angle that way. So this is how I remember this one. It will be a parallelogram if the diagonals, remember that means it goes from one vertex to another, but it can't be the side of the shape. If the diagonals bisect, that means cut in half, each other. So the diagonals have to bisect each other. So let's think about what that would look like in a diagram. So first of all, vertex to vertex, not the side of the shape. So one of those diagonals has to bisect, and the other one has to bisect. So bisect is cut in half. So if this diagonal is cut in half, then the two pieces would be congruent. If this other diagonal is cut in half, then these two pieces would be congruent. And therefore, you would be looking at a parallelogram. They have to bisect each other. They don't have to be the same as each other, but they have to bisect each other. So now I want to start looking at some diagrams and answering whether or not these are parallelograms. So let's take a look at the smaller one on the top. Is this a parallelogram? Well, it has a pair of opposite congruent angles, but not two pair. And it has a pair of opposite congruent sides, but not two. So I cannot prove that that is a parallelogram. Now, I know I drew it that way, and it sure looks like one, but I don't have enough marked on there to prove that it is a parallelogram. All right, then on this next one, I have kind of a long rectangular shape. Looks like that. There's no markings over here on the right side, so I'm going to focus over here on the left. I have a single right angle marked, so I do know that these two, the left side and the top side, are perpendicular. I know that this side's length and this side length are different from one another, but that's all I know, because I don't have any marking down here to say that this side is the same as that one, and I don't have any marking over here to say that this side is the same as this one. I don't have any marking down in this corner to say that it's the same as that one. So even though it looks like a rectangle, and rectangles are parallelograms, Without enough there, I cannot prove that to be a parallelogram. So let's take a look at this one. Do I have enough to prove that this is a parallelogram? This time the answer will be yes, because I have two pairs. Here's one pair of opposite congruent angles and another pair of opposite congruent angles. So my answer here would be yes. Why? Because I have two pairs or two sets of opposite. Now we can use certain abbreviations. So congruent is the wavy line over the equal sign, and angles is an angle sign with an S. Okay, so yes, because we have two pairs of opposite congruent angles. All right, the next one, and I should have made these a little bit smaller. I wasn't thinking about where my camera would be. I have parallel and parallel, so I have one set of parallel sides. That doesn't fit the definition. Remember, I would need two sets. And then over here I have a tick mark indicating length and a partner over here indicating those two are the same length. So that I have a pair of opposite sides that are congruent, and I have a pair of parallel, but they're not the same pair of sides. So this does not work. You may have been thinking, oh, does that ring finger one work? No, not in this case. Now down here it would, because here I have a pair of opposite sides that are congruent, and the same pair of sides are also marked as parallel. So this one, there is enough to prove it's a parallelogram. And here we have one pair of opposite, and there's no abbreviation for sides. One pair of opposite sides is parallel, that's the symbol for parallel, and congruent. So we can say that one for sure is going to be a parallelogram. All right, how about our drawing at the top? So I have two large lines that I drew here and two this way, and then markings on those indicate that the top and bottom line are parallel, and this left and right side are both parallel. So I have one set of parallel and two sets of parallel. So this one is by the definition, because the definition was the one that stated two sets of opposite parallel sides. Okay, how about this guy? Is this little one right here going to be a parallelogram? I'm not answering is it anything else. I'm just answering it, is it a parallelogram? And my answer here would be yes, because I have a pair of opposite congruent sides and another pair of opposite congruent sides. So yes, because we have two pair of opposite congruent sides. Okay. It would happen to be a more specific type of parallelogram, but that's not what I'm worried about today. Today I'm just looking at, do I have enough to say it's a parallelogram? All right, how about this guy? Is this one a parallelogram? Most of the time we're used to seeing parallelograms where the top and the bottom are horizontal, but that doesn't have to be the case. So here I have a pair of opposite congruent sides and another pair of opposite congruent sides. So even though it looks kind of like maybe a diamond, it's really not. It's actually just a parallelogram. So our answer here would be yes, and our reasoning, because marked on the diagram, we have two pairs of opposite congruent sides. All right, then what about this guy down here? Is this a parallelogram? Some of you are like, no, it's a rectangle. Well, it is a rectangle, true, but it is also a parallelogram. And we're going to talk more about that later in the week. Why is this one a parallelogram? Well, I have a pair of opposite congruent angles and a pair of opposite congruent angles. So we have two pairs of opposite congruent angles. Just a few more. All right, what about this guy? Is this one up here a parallelogram? So you'll notice I don't have anything marked at any of those. Maybe if I turn my paper this way. I don't have anything marked at any of the angles. And I also don't have anything marked as far as opposite sides go. The markings occur here and here as congruent, and here as congruent. So those happen to be on the diagonals. So this diagonal is cut in half, tick mark, tick mark. This diagonal is cut in half, double tick, double tick. So we are looking at a yes, this is a parallelogram. Why? Because the diagonals bisect each other. Remember, they have to each be marked. You can't just have one diagonal marked. You have to have a pair of them. Now this one tends to confuse people, this one here in the middle. You will notice I have nothing about opposite sides marked. I have nothing about any of the corner angles marked. And I have nothing about the diagonals marked. The only thing that's marked are these two pairs of vertical angles inside. But these are not opposite angles of the parallelogram. These are just vertical angles. So this one does not have enough to prove that it is a parallelogram. And sometimes people want to argue that with me a little bit. So I want to show you a diagram and put into perspective why this is not a parallelogram. So I think most of you would agree with me that the figure I just drew is not a parallelogram. Okay? It does not have two pairs of opposite parallel sides. These two are parallel, but these two are obviously not. If I continued them out, they would end up intersecting down here somewhere. But if I draw in their diagonals, I still make an X, and I still have vertical angles that are congruent. So this X in the middle says nothing about the outer shape. I could extend that in whatever direction I wanted. So we are definitely not having enough. If vertical angles are all that's marked, we do not have enough to say that's a parallelogram. All right, then we have this one. And I definitely should have done this one a little bit smaller because this one's a tricky one and I wanted to make sure to talk about it with you. So here I have one side marked with this one over here. Those are congruent. I have an angle up here, just a portion of that large angle, but also down here a portion of the large angle. And then this diagonal is cut in half, so that one is bisected. So here's what I wanted to talk to you about. This triangle right here has marked on it a side, an angle, and a side. And this triangle over here has marked on it a side, an angle, and a side. So these two triangles are going to be congruent to each other. So if these two triangles are congruent to each other, then CPCTC tells me that their parts are congruent. So not only is this side and the one at the very end, and this side congruent, but these two sides would be congruent as well. And that right there now changes my answer, because this diagonal is bisected and this diagonal is bisected, so I can say yes, because the diagonals bisect each other. Now remember, you can't assume anything. I didn't assume those triangles were congruent. I proved they were by the side angle side postulate. So there might be things that you know to be true that you can prove to be true that will help you figure out whether or not it is a parallelogram, but I do want you to keep in mind you have to look for some of those things. You can't just assume them to be true. You'd have to show that that would be the case. So today in your assignment you're going to be looking at some figures and answering whether or not they're parallelograms. If they are, make sure, just like we did here, that you tell which of those 5 proving parallelograms pieces of information you're using, and I strongly encourage you to make that hand, trace it, write on it if you haven't already, so that you can make sure that you have those 5 proving parallelograms pieces readily available for you, not only on the homework but also for the quiz when we get there.